No. So my research is investigating potential acoustic indicator for sound quality standard of Ecocity frameworks. Feel free to ask me questions if there is something that you want to know that is right here that you don't understand. So this is the agenda. First, I'll start the introduction and then literature review, following with problem statement, methodology, data analysis, limitation, discussion, and conclusion. So first of all, Ecocity is a community of settlement that is built in a sustainable manner by utilizing renewable resources and generating less waste while preserving a healthy ecosystem for living organisms. So currently, it is divided into 8 different levels, ranging from unhealthy all the way to Gaia level. It is evaluated by 4 major pillars, which are urban design, biogeophysical features, socio-cultural features, and ecological integration. Each pillar has several standards, and combined altogether resulted in 18 standards. Sound will be included under biogeophysical features. And the definition of sound is an energy traveling in the form of sound path measured in dB, dBA, watt per meter squared, and sounds. Many regulations have tried to regulate noise in the city by introducing maximum sound pressure level. However, the sound has semantic contents, it has spectrum, roughness, sharpness, and other factors that determine whether the sound is pleasant, called noise. This is why we are investigating acoustic parameters in maximum sound pressure level that is currently regulated by WHO. So these are the 4 potential acoustic indicators, which are balanced soundscape, psychoacoustic annoyance, temporal sound level variance, and spectral gravity center. The case study is Olympic Village. So these are the current municipal acoustic regulators. There are the regulator of Olympic Village, which are WHO, CMHC, LED and BREEAM, and City of Vancouver Noise Bylaw 6555. Moving to the literature review. Ambient noise is categorized into ambient restorative sound, such as water sound, bird song, insects, water creatures, animals, and unwanted ambient sounds such as hiss, tapping, and traffic noise. What is a balanced soundscape? Balanced soundscape is a soundscape where people still have the ability to talk or express without getting interruption from the sound input or impression from the surrounding. Balanced soundscape is divided into 3 categories, which are biophony, anthrophony, and geophony. Biophony is sound that is produced by biological organisms such as birdsong, insects, frogs, and animals. Anthrophony is sounds that is produced by human activities, and geophony is sounds that are produced by earth, such as water, earthquake, and winds. Temporal sound level variance is how often the sound change, and spectral gravity center is related to analyze the quantity of low frequency that exists in soundscape in terms of pitch variation in the sound quality. So what is psychoacoustic? Psychoacoustic is a field in acoustic that study human perceptions and respond to sound. It is divided into 2 different measures, which is psychoacoustic annoyance and sensory pleasantness. The difference between these 2, psychoacoustic annoyance is more related to human comfort, and sensory pleasantness is usually used for development of engine noise, which is why sensory pleasantness is not within the scope of the research of my thesis. So the problem statement is, in 2017, sound quality is first time proposed to be added into the Ecocity sound quality. And in 2019, in Ecocity workshop, the concept of sound quality is developed. It is later discussed that sound has semantic contents and it cannot rely only on maximum sound pressure level, like all the regulation these days. This is why the research is aimed to test other acoustic indicators that is that can improve how sound quality can be evaluated. The methodology, first of all, is reviewing the case study, which is Olympic Village. It is approximates Ecocity level 1. It has 252 affordable housing, and all buildings have achieved LEED gold with 16,000 population. And the data collection was 38 total data measurement points, and each point we measured 3 times 3 minutes interval. We gathered 71 survey respondents based on ISO standard. And these are the measurement points. The yellow ones is pretty much the first day, the red one is the second day, and the green one is the last day. So we ended up didn't use the first data because there are some variation that is not working. As you can see here, the red data is spread out through the water area, and it is measured on the weekday data, and then the green ones were measured on the weekend. So this is the sample. This is actually the poster when we tried to collect the survey. We did because it was during COVID, we were prohibited to kind of like give out a survey in terms of paper. So respondents are invited in terms of scanning the QR code with their phone, and it will link to a Google survey, which has all these questions on the right side, according to ISO standards. And they each like enter a draw to win like 25 Amazon gift card after that. The survey was also, the methodology was also approved by the BCIT Ethics Review on January 12, 2021. And then the first thing, to analyze the soundscape, we develop, there is a soundscape theory. We are using a triangulation methodology by combining and analyzing the data measurement result, the survey result, and sound analysis performed by the researcher. ISO 12913 has two-dimensional soundscape diagram at which soundscape characteristic data measurement points will fall. In this research, we developed sound quality, which is the vibrant calm quadrant along the pleasant axis. And the next one is the soundscape methodology. The next one is soundscape taxonomy, sorry. This is used to perform sound analysis by the researcher. The finest level of the taxonomy is being used to quantify the number of sound sources in Olympic Village. And in terms of data analysis, all the data measurement results are processed into the software and later into regression analysis. There are some regression analysis that is performed on my research, which is binary logistic regression, multilinear regression, and principal component analysis. So moving on to the data analysis and resource and results. These are the potential physical, classical, and additional acoustic indicator being analyzed in the research. Start with sound power level, whether weighted and unweighted, biophony and anthrophony ratio, normalized different soundscape index, which fall under balanced soundscape theory, spectral gravity center, temporal spatial sound level, TSLV, and psychoacoustic annoyance. In psychoacoustic annoyance, there is loudness, loudness maximum, loudness percentile, sharpness, roughness, and fluctuation strength. These are the results. I can just quickly skim through it. And the survey result says that on the weekend, the dominating noise is the human beings, and the less dominating noise is traffic and other noises. The background is mostly dominated by natural sounds. The respondents said that the weekend noise is pleasant, vibrant, eventful, somehow chaotic, and monotonous at certain points. More than 50% agreed that surrounding environmental is very good and appropriate to the present place, while on the weekday, respondents agree that dominating noise is traffic noise, other noise, and natural sounds, while the background is dominated by human beings. And they describe the soundscape as pleasant, vibrant, eventful, monotonous, and calm. And more than 50% agreed the surrounding environment is good or very good and appropriate to the present place. So for the soundscape analysis, the results shown there are 20 points in the sun quality zone. 45% of the data is from the weekend data and 55% from the weekday data. Seeing the proportion of the weekend and the weekday data being equally as much in the sun quality zone means that each day is data contribute equally to the sun quality zone. Therefore, we decided to also combine the data of weekday and weekend to predict which acoustic indicators that actually predict the measurement points being in the sun quality zone. The next one, this is a 2D soundscape analysis map out in Olympic Village map. As we can see, there are points that is considered outside pleasant and calm quadrant. The orange one is inside the pleasant and vibrant, and the yellow one is pleasant and calm. As we can see here, the proximity to the water or to the park doesn't really tell whether the data measurement point is inside the sun quality quadrant or outside the sun quality quadrant. So therefore, proximity to water, to plazas, or like to garden doesn't affect our research. So the next one is the taxonomy method. If you remember on my previous methodology, we count that the source of each sun source at inside the sun quality zone and outside the sun quality zone. Outside the sun quality zone, we have a total of 248 sun source, and inside the sun quality zone, there's 294 sun source. Total both added equal to 542 sun source. And then here, this table is summarized the taxonomy of inside and outside the sun quality. Inside the sun quality zone, it has more total sun source coming from the wind, bicycle, rail traffic, air traffic, footstep construction, ventilation, and music, while outside sun quality zone, it has more total sound coming from water, dog barking, food trucks, engine, voice singing, and other human noises. And then the statistical analysis, which is the binary logistic regression results, shows that PA, loudness maximum, loudness percentile, and sound power weighted, has a direct correlation with why the measurement point is inside the sun quality zone. And we also conduct a matrix plot analysis, and which show like the strong correlation between each physical, classical, and additional acoustic indicator. And the result are this, which I believe like it will be boring if I read one by one. So the next one is principal components analysis. Basically, principal components analysis, if we have a look at the graph on the left side, any psychoacoustical or acoustical indicators that are located close to each other has a strong correlation. So we can see here that PA, or psychoacoustic annoyance, and its supporting parameter has a cross correlation, and then NDSI, which is a balanced soundscape parameter, has a strong correlation with psychoacoustic annoyance. And we can also see that sound power level, the weighted one, is strongly correlated with PA. That was proof on previous study that sound power level and psychoacoustical annoyance is strongly correlated. What next is the limitation of my research is the efficiency of data collection causes non-random data measurement points. Thus, the analysis of the data needs to be done independently between the data collected on the weekday and on the weekend, even though on the sun quality soundscape analysis, the data were combined. And the discussion is that two-dimensional soundscape analysis result in 80% of the data measurement points located in the sun quality zone, which is vibrant and calm quadrant. Psychoacoustic annoyance value of 28 to 52 place the data measurement points in sun quality zones. In the research, the maximum and minimum psychoacoustic annoyance value recorded at 84 and 28 respectively. Loudness maximum, and loudness percentage within those values are placed the data measurement point in the sun quality zone. and weighted sound pressure level value of 66 dBA or less place the data measurement points in the sound quality zone. In this research, the maximum and minimum weighted sound pressure level values recorded are 73 dBA and 58 dBA respectively. And then in this graph, it shows the point that are inside the sound quality zone and outside the sound quality zone. If we can see the point 11, 12, and 13 have a high sound basking noise, where the respondent of the survey reported the soundscape at these data measurement points are pleasant. But if we see at point 2A, 2B, 3, 4, 5, 6, 7, and 19, it is marked as outside sound quality zone. This area are plaza where people usually sit and hang out. Looking at the sound taxonomy, it is dominated by kids screaming, food trucks, traffic sound. And if you can see point 3, 4, and 19, 3, 4, and 19, it has considerably high traffic noise due to measurement points being close proximity to intersections where cars are accelerating and decelerating. Point 25 is also outside the sound quality zone. Point 22, 23, 28, 38, and 37 all have also close proximity to the road, and also it is outside the sound quality zone. What's funny here in my thesis, we found out that bicycle, rail traffic, air traffic, footstep construction, and ventilation are mostly the dominating noise in the sound quality zone, even though we know logically that this sound are not pleasant. However, the conclusion is this bicycle sound, rail traffic, air traffic, footstep construction, and ventilation are not sufficient to place the data measurement points in the lo-fi soundscape, but is in the hi-fi soundscape, where is the combination of all these sounds are forming a background noise. In a way, even though these sounds are dominating an axis, people are still able to communicate without any intervention from these noises. And to summarize my research, the research was to investigate which acoustic indicator that is suitable for sound quality benchmark and Ecocity framework, in addition to maximum sound pressure level. And we investigate 4 sound indicators, which are balanced soundscape, psychoacoustic annoyance, temporal sound level variance, and spectral gravity center. And we determined that the graph of ISO 12913, the vibrant and calm quadrant as sound quality zone, and performing binary from the binary logistic regression, we predict that psychoacoustic annoyance, weighted sound power level, loudness maximum, and loudness percentile is the indicators that determine the data measurement point in sound quality zone. And there is a strong correlation between weighted sound power level, loudness, and psychoacoustic annoyance. The result of the measurement correlates significantly with the type of activities recorded during the measurement. So the conclusion is psychoacoustic annoyance that has a value between 28 and 52 are recommended to be in addition for sound quality parameters in Ecocity framework. And that's it. Do you have any questions?
Awesome.